please, you guys, make sure you go back and study these notes. You have to go back and remember about the converse, inverse, contrapositive, and biconditional. The most important thing is for you guys to keep straight the difference between the converse and the inverse. The converse is the one where they move. The hypothesis and conclusion switch sides. They reverse. That's converse. The inverse is the one where everything is just negated. They don't move. They're just turned into the opposite of what they are. They stay in the same place, though. Of course, the contrapositive is the one where both things happen. They switch places and they're negated. Biconditional is the one that has if and only if in between. Here are some examples that you can study on your own. Be familiar with this vocabulary. Conditional, that's an if-then statement. Inductive reasoning, you need to know this vocabulary. Inductive reasoning, that's when you're looking for a pattern. As opposed to deductive reasoning, that's when you're just using logic and you're basing your steps on some accepted idea, accepted facts. Mostly what we do when we're solving equations and things like that, we're using deductive reasoning, going from A to B to C, using adding something to both sides, subtracting from both sides. That's all deductive reasoning, a chain of facts. Okay, look at problem number 1. The number of feet of the perimeter of a rectangle is always greater than the number of square feet in the area. Find a counterexample. A counterexample is an example that will prove the statement false. So it says the number of feet is always greater, the perimeter will always be greater than the area. So a counterexample would be one where the perimeter is less than the area. So did anybody find a counterexample?
Square feet.
We're talking about a rectangle, okay? So I need the dimensions of a rectangle. Give me length and width. That would be a counterexample to this problem. Okay, Andrea says 6 by 5. Okay, let's see if this is an example that proves the statement false. That would make this a counterexample. Using Andrea's example, the perimeter. What would the perimeter be? And the area. How would I find the perimeter of this thing? What does perimeter mean? People in the front row? Second row? Street was kind of doing it. How do I do the perimeter, Miss Street? You add up all the sides. So the perimeter, I have 2 6s and 2 5s. So what's the perimeter going to be? 22. Okay? So the perimeter is 22. How do I find the area? What's the area going to be? Is base times height, length times width. So what's that? That's 30. Now, according to the statement, the perimeter is always greater than the area. But here we have the perimeter being less than the area. So yes, that would be a counterexample. It's just an example that proves it wrong. Okay? Look at number 2. If David goes to the mall, then his brother will go to the movies. David's brother did not go to the movies. What does that tell you? Right. That means David must not have gone to the mall. Okay? So that's really common sense, but that's logic. We're doing logic now. Okay. Ella factored the first 5 terms out of 10 trinomials on a test. Each one factored into a pair of binomials, and she made this statement. All the trinomials on this test will factor into a pair of binomials. Is this a counterexample, inductive reasoning, deductive reasoning, or a conditional statement? Hold up fingers for me on this one. Hold up one finger for counterexample, 2 fingers for inductive reasoning, 3 fingers for deductive, and 4 fingers for conditional statement. Show me on your fingers right now what you think is the answer to this question. People that are watching this video in another class, you hold up your fingers right now as well. Keep them up. Collecting data. Okay, put them down. I sort of saw a combination of B's and C's. Half of you guys were saying inductive and half of you were saying deductive. Now, did she make this statement based on mathematical rules and laws and theorems, or did she make this statement based on a pattern that she observed? She made this based on a pattern. Okay? She noticed she did the first 5 and they were all binomial. So she guessed that the rest would be. She's working on a pattern. Now remember, between inductive and deductive, inductive is the one that means you got it from a pattern. Deductive is the one where you're using theorems and mathematical laws and rules. That's deductive. If you're following a pattern, that's inductive. Okay, so the answer to this one was B. So memorize that vocabulary. Inductive is the pattern, the one with the pattern. What is the converse of this statement? Show me on your fingers the converse of the statement. Put them up. Or have you not had time to read it? All right, in my first period class, everybody voted for C. Now remember, converse, that's the one where the statements switch places. Okay? So something about eating breakfast should definitely be first, and something about hungry should go second. Okay? And that's it. So, did not eat breakfast should be first, and you are hungry, something about being hungry should be second. So people said C. If you did not eat breakfast, then you are hungry. That is correct. Okay, look at number 5. Find the value of x. How many sides are on this shape? 7. Okay, so we need to start by knowing the total degrees so I can make an equation. All right? Just like we used on the previous page. The total degrees are going to be n minus 2 times 180. All right, we already knew that from the previous paper. So in this case, that's going to be 7 minus 2 times 180. Okay, so that's going to be 5 times 180. So what does that come out to be, you guys? 900. So the total degrees are 900. So let's make an equation. Let's start by adding up all of the constant terms. Okay? 1, 2, 3. Take those 5 numbers and add them up for me, please.
645.
645. So the constant terms add up to 645. Now let's deal with the variable expressions. Obviously, if I put together 2x and x, what does that make? 3x. So 3x plus 645 would equal 900. So then we subtract 645 from both sides. And that will give us 3x equals 255. Then we divide both sides by 3. And that gives us x equals 85. Alright, and that's how you do number 5. Now let's hop over to number 6. These are exterior angles. So we know that the total for all the exterior angles will be 300. we don't need to do n minus 2 times 180 or anything like that. It's always 300 for exterior. Let's see. Let's combine these like terms. Let's start with the x's. 4x plus x plus x. That's 6x. So I've got 6x. Now, as far as the constants, I have 137 plus 43. Now the plus 1 minus 1, those are just going to cancel each other out. So that makes 180 as far as the constants. So I have 6x plus 180. Let's subtract 180 from both sides. So that's going to leave 6x equals 120. So dividing by 6 on both sides, that's going to give me x equals 20. Alright, so that is how you do number 6. Now, take a look at problem number 7. Be careful, you guys had trouble with this back in the day. Now, we mentioned this idea on the previous lesson, the part 11 lesson, but I've written it again here. Of course, if we have the total degrees and we divide that by the number of sides, that should give us one angle anytime we have a regular polygon. So, if I'm talking about interior angles, I can find the total by doing n minus 2 times 180. We'll let n represent the number of sides. If I am talking about exterior angles, the total is always 360. So look at number 7. Interior. The interior angle of a regular polygon is 150 degrees. How many sides does the polygon have? So, looking at this model, okay, total degrees over number of sides equals one angle. Let's set up and see what we've got. The total degrees, I don't know that, but I can figure it out. I don't know why I put a line there. The total degrees, because okay, the total degrees, I don't know what it is, but I can write an expression for it. So an expression for the total number of degrees would be n minus 2 times 180. And we will use, we're using n to represent the number of sides. So this is an expression for the total degrees, n minus 2 times 180 over the number of sides. Really, the only part of this that I know right now is that the one angle is 150 degrees. That's all I know. Now I need to find the n that would make this happen. Now I could solve the equation. I could multiply by n, I could do a bunch of things, but the easiest thing to do is to use the TI-30 to find this answer. So let's take a look at that. What we will do is let's type the left side of this equation into the calculator as a function, and let's see what value of n it takes to give us a result, an output of 150. This is what I mean. The left side of that equation was n minus 2 times 180. Of course, I'm just going to use x. I should put this in parentheses though. So parentheses x minus 2 times 180 Alright, so there's my n minus 2 times 180. And of course in the bottom, we just had n. So I'll just put x. Okay, you know what? This entire thing needed to be in the function part of the calculator. I meant to hit table first. Sorry about that. So hitting table, now I'm going to do it. So x minus 2 times 180 over x. So now I've typed in my the left side of that equation as a function. If I go ahead and look at a table of values for this, okay, I am being given, so it's saying, remember the output of this function should be one angle, because we put in the total divided by the number of sides, we put in those expressions. That should equal a single angle. So as I go down this list, I'm looking for which number of sides is going to give me a single angle of 150. So a pentagon, that's going to give me each angle is 108. A hexagon, each angle is 120. That's going to be some decimal for my heptagon. An octagon, each angle is 135. Getting closer. A nonagon, each angle is 140. Decagon, 144 degrees each. Some decimal. And then there it is. When you have a 12-sided figure, then you're going to get 150 degrees for each angle. So that is a good way to do it, is just to type this expression in, and it will, and just look for which value of x will give you the angle that you're looking for. Okay. Alright, so we used our TI-30, and it told us that n would have to be 12. Number 8 is going to be a little simpler. Because we're dealing with exterior angles, for exterior angles, we're still doing the total divided by the number of sides should give us one angle, but the total is just 360. So 360 divided by the number of sides should equal the one angle that we're given. Okay? Each angle is 20. And this is really easy to solve, especially if you remember the shortcut that I taught you. When the variable is in the denominator, we should be able to reverse these. So the equation then becomes 360 divided by 20 is equal to n. Alright, if you put that in your calculator, you're going to get 18. Okay, so that's the answer number 8. Look at number 9. Margaret solves the equation. She justifies each step by providing a reason. What type of reasoning is Margaret using? Okay, she started with 3x plus 2 equals 8. That was given. Clearly, she subtracted 2 from both sides. Alright, that's the subtraction property of equality. She concluded that 3x would equal 6. To get to the next step, she must have divided both sides by 3, and then she gets x equals 2 using the division property. Well, anytime you are using a sequence of accepted facts to get from one step to the other. Is that going to be inductive or deductive reasoning? One of these is the one where we're using facts, accepted facts leading us like a chain from one step to the next. And the other one is the one that means we are learning from a pattern and basically making a guess that the pattern will continue. So which one is the one where we're following accepted rules? Deductive is what was used because she's following accepted rules. The subtraction property of equality, the division property of equality. Those are accepted mathematical rules, and that she followed to arrive at her conclusion. She wasn't just observing a pattern. The one that would be a pattern would be inductive. If you're guessing from a pattern, it's inductive. If you're following the facts or rules, that's deductive. Now, on a previous lesson, we learned that an exterior angle, like 5 for example, should equal the sum of the two remote interior angles. So for example, looking at the 5, that should equal the sum of the 3 and the 1. Okay, so here I have angle 5, the exterior angle, equaling the sum of the 3 and the 1. So that's true. Look at this one. I'm going to have to erase. Alright, look at this one. The measure of angle 4. The measure of angle 4 should equal the sum of angle 3 and angle 2. And that's exactly what they have. Angle 3 plus angle 2 should equal angle 4. Alright, so that's true. Look at angle 6. Does that fit the pattern? Angle 6. Angle 6 should equal the sum of angle 1 plus angle 2. Is that what they have? No, it's not what they have. They have angle 4 plus angle 5. Those are more exterior angles. There's no rule like that. So this one is false. We're supposed to find the one that is false. So D is going to be the answer. Now we haven't looked at A yet, so let's look at it now. Let's see. Angle 6 is the exterior angle. Okay? So the question is that bigger than angle 2? Well, of course it is. Considering that angle 6 is the size of angle 1 plus angle 2 combined. The only way that it can equal the sum of both of these angles is if it's definitely going to be bigger than either one of these by itself. So it is definitely true that angle 6 is bigger than angle 2. Looking at it another way, and sometimes the drawings are not to scale, so we can't trust this completely, but angle 6 is an obtuse angle that's obviously bigger than 90 degrees. Whereas angle 2 is an acute angle. It's definitely less than 90 degrees. So this is definitely going to be bigger than that. Alright, so that's the end of part 12.